in the vast South Pole Aitken Basin, a region so remote and mysterious that it had remained almost completely unexplored until now. The South Pole Aitken Basin is no ordinary crater. It is the largest known impact structure on the Moon and one of the largest in the entire solar system. Stretching over 2,500 kilometers wide and plunging more than 8 kilometers deep, this basin offers a unique window into the Moon's geological history. Because of its depth, scientists believe it exposes material from the Moon's lower crust, and perhaps even its mantle, which has been sealed away for billions of years. Landing here meant unlocking secrets buried since the earliest days of our solar system. But landing on the Moon's far side is no simple task. Unlike the near side, which constantly faces Earth, the far side is completely hidden from our planet. That means there is no direct line of communication. Every instruction, every transmission, every signal has to be relayed through satellites orbiting the Moon. This makes the far side one of the most challenging and dangerous places for robotic exploration. Yet China not only managed to land its SITES probe there, it also succeeded in carrying out a complex series of automated tasks, drilling beneath the surface, collecting samples, and safely sealing them for return. The mission lasted an incredible 53 days. During this time, the probe performed delicate maneuvers with precision that stunned the global space community. Using a new generation of autonomous systems, Chang'e 6 drilled deep into the regolith, the blanket of dust and rock fragments, covering the Moon, and extracted material that no human or robot had ever touched before. These weren't just surface samples scorched by solar radiation. These were layers of pristine lunar soil, untouched for billions of years, holding potential clues about the Moon's true composition and history. After completing its mission on the lunar surface, Chang'e 6 performed another near-impossible task, launching the sealed sample container back into lunar orbit, where it docked with the return module. This feat alone demonstrates a level of technological maturity that only a handful of space programs in history have ever reached. Finally, after weeks of travel, the capsule carrying the precious cargo re-entered Earth's atmosphere and parachuted safely down, delivering its contents for study. For China, this was more than just a scientific success. It was a statement to the world, proof that their space program has evolved into one of the most capable and ambitious on the planet. While the United States, Russia, and other nations have explored the Moon in the past, no one had ever achieved what Chang'e 6 did, a fully robotic mission to the far side, a place once thought impossible to reach, with a successful return of samples. The implications of this achievement cannot be overstated. It marks the beginning of a new chapter in lunar exploration, one where China is no longer just a participant, but a leader. And what those samples revealed upon their return to Earth would send shockwaves through the scientific and geopolitical world alike. Before we dive in, hit that subscribe button and turn on notifications. You don't want to miss any updates on the universe's deepest secrets. And if you love exploring hidden mysteries and unexplained discoveries, give this video a like so we know to keep uncovering them. When the Chang'e 6 capsule finally touched down on Earth, scientists wasted no time rushing the precious lunar cargo into carefully controlled laboratories. Inside were fragments of dust, soil, and rock collected from the far side of the Moon, material that no human eye had ever seen before. The moment researchers opened those sealed containers, the world of planetary science changed forever. Early examinations immediately revealed something astonishing. The samples contained traces of water ice embedded within the lunar regolith. For decades, astronomers had speculated about frozen water lurking in permanently shadowed craters near the Moon's poles. But direct physical evidence had remained elusive. Now, with the material in hand, there was no longer any doubt. Water, the most vital resource for life, for breathable oxygen, and even for rocket fuel, was present on the far side of the Moon. But the surprises didn't stop there. As researchers dug deeper into their analysis, they uncovered another revelation: the presence of helium-3, an isotope almost non-existent on Earth. For scientists and futurists, helium-3 has long been considered a potential game-changer. It is one of the most promising fuels for nuclear fusion, a form of energy that could theoretically provide humanity with limitless, clean, and nearly waste-free power. On Earth, only a few kilograms of helium-3 exist naturally. On the Moon, however, billions of tons may be embedded in its soil, deposited by billions of years of solar winds. And now, thanks to Chang'e 6, we know with certainty that this rare isotope is not just a theory. It's a reality waiting to be harnessed. Then came perhaps the most mysterious discovery of all. Some of the samples showed unusual silicate and metallic oxides with crystalline structures that had never been documented before. Their exact composition remains closely guarded, but leaked reports suggest these materials may have unique electrical and thermal properties. In other words, they could one day form the backbone of next-generation electronics, advanced superconductors, or even military technologies that today sound like science fiction. Think about what this means. In one mission, China uncovered 3 resources that could reshape the future of humanity. Water, the foundation of life and exploration. Helium-3, the potential key to solving the world's energy crisis. And exotic new materials, capable of transforming industries from computing to defense. Each one of these findings alone would have been historic. Together, they paint a picture of the Moon not as a barren wasteland, but as a treasure chest of unimaginable value. The implications go beyond science. Whoever controls access to these resources could control the future of energy, technology, and even space travel itself. And for the first time in history, it is China, not the United States, that is holding the samples and setting the pace. These discoveries are more than just scientific footnotes. They are the spark that could ignite a new space race, one unlike any the world has ever seen. For decades, scientists have dreamed of a future powered by nuclear fusion, the same process that fuels the stars. Unlike traditional nuclear fission, which splits atoms apart and creates dangerous waste, fusion combines light elements like hydrogen into heavier ones, releasing enormous amounts of energy with almost no radioactive byproducts. It is the holy grail of clean energy: limitless power, no greenhouse gases, and virtually no long-term waste. But there has always been one challenge: finding the perfect fuel. Here on Earth, the fuels we've experimented with, such as deuterium and tritium, have limitations. Tritium is radioactive, dangerous to handle, and produces neutrons that can make reactor walls brittle over time. That's where helium-3 comes in. This rare isotope of helium is non-radioactive, produces very little waste, and in theory, could power a fusion reaction that is safer and far more efficient. In fact, just 25 tons of helium-3 could provide enough energy to power the entire United States for a year. The problem? Earth barely has any. Our planet is shielded by a magnetic field that blocks the solar wind, preventing helium-3 from ever accumulating here. But the Moon is different. For billions of years, its surface has been bombarded by the solar wind, embedding helium-3 deep into its regolith. Scientists have long suspected that the Moon, especially its far side, might hold vast quantities of this fuel. And now, thanks to Chang'e 6, we finally have confirmation. China's samples showed concentrations of helium-3 that were not only present, but higher than anyone expected. This discovery is a turning point. It transforms helium-3 from a theoretical dream into a tangible resource, one that could one day be mined, refined, and brought back to Earth to revolutionize how humanity powers its cities, industries, and technologies. Imagine a future where oil and gas wars are relics of the past, where coal plants stand abandoned, and where humanity taps into a virtually inexhaustible energy supply from space. Entire economies would be reshaped. The balance of global power could shift overnight. Countries that gain access to lunar helium-3 would hold the keys to the world's energy future. Of course, there are still hurdles. Fusion reactors capable of efficiently burning helium-3 are not ready yet. Scientists are making progress in laboratories across the world, but commercial fusion power has always been called just 20 years away, and yet the existence of accessible helium-3 may change everything. Knowing that such a resource is real and obtainable could accelerate research, funding, and innovation, pushing fusion technology toward maturity faster than anyone predicted. And here lies the geopolitical weight of China's discovery. By securing physical proof of helium-3 on the far side of the moon, China isn't just advancing science, it is positioning itself at the forefront of what could become the most valuable energy race in history. The nation that first manages to extract, transport, and harness helium-3 won't just lead in space exploration. They could dominate the global energy economy for centuries to come. If helium-3 represents the promise of limitless energy for Earth,